Okay, today we'll be working on lesson 6.5, base E and natural logarithms. Let's start with the first question. Now, as you can see, when you look at the first question, it's not base E. So this is a review of a previous lesson, which is 6.4. Now, to solve something like this, the first thing that you should do is try to get, since the variable is in the exponent, so it means you have to use log to solve. So let's just put that, change this to a log equation. So log base 6 of 8 is equal to 3x plus 1. Now go ahead and try to find log 8 base of 6 on your calculator, and you will see that it's 1.161 equals to 3x plus 1. Just a reminder, to find log on your calculator, you can just go to math, then go all the way down to log base, and then you can press your argument and base, or you can plug it in as log of 8, close parentheses, divided by log of 6, and you will get the same answer. So both methods are right, and you will get 1.161. Now to solve for x, you would subtract 1 from both sides, so you get 0.161 equals to 3x. Then you divide by 3 to find x, so x would be equal to 0.537. Now go ahead, pause the video and try to do the next one on your own. Remember, every time your variable is in the exponent, then the best method is to use log to solve for it. Now I hope you tried, and x would be equal to 2.378, so let's do this together. To change this to a log, you would have log base 5 of 72 is equal to x squared minus 3. This on the calculator would be equal to 0.657 is equal to x squared minus 3. Now to solve for x, you would add 3 to both sides. You get 5.657 is equal to x squared. Now remember, every time you want to solve for a square, you take the radical of both sides. So x would be equal to 0.378. This is how you would solve every time you have a variable in the exponent. Now let's talk more about natural logarithm. Now, before we heard something called a logarithm. It means a log having a base of whatever number and having an argument. So this is just regular log. A common log is when you have a log of base 10. So we know that the log is base 10, for example, of 25, but you don't have to write it. So every time you see a log with no base, you know that the base is 10, and this is why it's called common logarithm, and this was our lesson 6.4. Now in this lesson, we're going to learn how to, or what to do with natural logarithms. Natural logarithms, we're going to see this more in science, and basically you use a term called e, and this is a constant which is almost equal to 2.7. To locate the e on your calculator, it's going to be under the division sign, so you do second divide to get the e. Again, it's just like pi in math. Pi is equal to 3.14. Now you know that e is almost 2.7. You can always use the button on your calculator to get the exact value. So natural logarithm, to be able to differentiate between all of those, so mathematicians have created something called ln, which means log base e. So where is ln on your calculator? It's the button next to the 4 under log. So if you press ln of 5, it will give you a value. So remember, ln is nothing but just log base e of 5. But in order not to have so many logs, ln means natural logarithm, n stands for natural. So let's see how we can do that. Ln 4, so go ahead, press ln on your calculator of 4, close parentheses, and you will get that ln 4 is 1.386. Now e to the power 5. Again, you can press second ln. You will get the e to the power of something on your calculator. You press the number 5 and you will get e to the power 5, and you will get the final answer, which is equal to 148.41 0.413, and that would be the value. Another way to do it on your calculator, you can press second division sign. You will get the e, and then you do to the power of 5. So there's two different methods. You can use any way you like. Now let's move on to the third example. Remember, every single time you have a variable in the exponent, you have to use log to solve. Now since this is base e, it means I have to use ln. So change this to a log. So you can, if you want, let's use log until you get comfortable with it. Now the base is e, so I'm going to put e over here. The argument is going to be 5 is equal to x. This is how we usually do it. The base goes here, the argument goes inside, and the exponent is the answer of the log. But we learned something called ln. So instead of log e, I can put ln of 5 is equal to x. And this is something that we found maybe earlier. 1.609. This is how you solve it. Now before I move on to the fourth example, I'd like to do more like this. So let's try to do 5e to the power x minus 7 is equal to. The first thing you should do is try to isolate the e. So you add 7 to both sides. You get that 5e to the power x is equal to 2 plus 7, which is 9. Then you divide by 5, you get that e to the power x is 9 divided by 5, whatever that is, let's say 1.8. Now this is something like what we solved earlier. Again, every time the variable is in the exponent, you have to use log to solve. So log base e of 1.8 would give you x. Again, this is something that we know, it's ln. So instead of log base e, you can just put ln of 1.8 is equal to x. So x would be 0.587. You can plug that in your calculator. Now let's move on to the last example, 3e to the power x plus 2 equals 4. Please pause the video, try this on your own, and then check the answer. You should get x is equal to negative 0.405. Now let's see how we solve this. Again, you have to subtract 2, isolate ex. So 3e to the power x is equal to 4 minus 2, which is 2. Divide by 3. So e to the power x is equal to 2 over 3. Now again, every single time the variable is in the exponent, you have to use logarithm to solve. But since it's base e, let's just write ln from now on of the argument is equal to x. So x is going to be ln of 2 over 3, which is equal to negative 0.405. Now I hope this was helpful. We'll have more practice soon. Now this is how you would do every time you have e to the power x. Now let's move on to this example. Ln of x is equal to 0.6931. Now, remember, since the argument is unknown, then you have to use exponential to solve for this. Now, what's the base of the ln? The base is e. So e to the power of this will give you x. It's exactly what you do usually when. So as you can see, every time you have something like this, you use the base. In this case, it's e, since this is natural logarithm. So e to the power of this number would give you x. So e to the power of 0.6931 would give you x. Now you just need to plug this in your calculator. You do that by going to second ln, and then you enter 0.6931, or you can go to second division and then press the power button to get that, and you will get that x is 1.9999, which is almost 2. So that's going to be your answer. Now again, we'll have more practice on those, but please, if you need to watch the video again to review those, go ahead and do that. Now let's move on to word problems. Suppose you deposit $1,000 in an account paying 2.5% annual interest, and then this amount is compounded continuously. What is the balance after 10 years? Now every time they tell you compounding continuously, so underline that, you would use the formula A equals P e to the power RT. So A stands for the initial amount, which is 1,000. A stand for the final amount, like we used to do. B, or P, stand for the initial amount. R stand for the percent, which is the rate, and T stand for time, so write those down. A stand for final amount, P stand for initial amount, R stand for the rate, which you have to write as a decimal, and T stand for time. So they're asking what is the balance after 10 years. So they want the final amount after 10 years. P stands for the initial amount, which is 1,000. E to the power R, you have to change this to a decimal, so 2.5, move the decimal twice back. So it's going to be 0.025, and T stands for time. So you can plug this all in your calculator. You can plug in 1,000, then press second ln to get e to the power, open parentheses, and type in 0.025 times 10. And you press enter, you get that the final amount is going to be 1,284.03. So your amount did not really add up by much after 10 years. It only added by 284, but that's fine. Now, how long will it take for the balance in your account to reach at least 1,500? At least means it can be 1,500 or more. Think of it, 1,500 or more. When you say at least, I want $10, it means you want $10 or $11 or $12. So you want it to be at least 1,500, means equal to 1,500 or more. And the amount is whatever equation you had from the beginning. So the initial amount was 1,000, e to the power. The rate is going to be 0.025. And they're asking when or how long, so they want the t. Now remember, like we used to do, how would we solve something like this? You would put this in y1, put this in y2, and you try to go to second table and try to find the value when your answer is going to be equal, greater or equal to 1,500. Now this will give you, this is the easy way to do it, but if you want a more precise method, you would go to second, you would graph it first, you would need to fix your window if you need to be able to see the two graphs, and then you would go to second, so number one graph to fix your window to be able to see the two graphs. Then you go to second trace, you go to number 5, and then you press enter 3 times because you want to find the intersection, and then you will get that the t is going to be greater or equal to 16.2. If you use the table, you're going to get the number 17. So this is a more precise answer, but the other one is acceptable as well. So if they say how long it's going to take you to reach this amount, remember, if it's at least, it means you want it to be greater or more or equal to 1,500. How long, it means everything is given except the time. And for something like this, always put this in y1, this in y2, then you can use any method to solve. Now I hope this was helpful. We'll talk more about this in class with the practice sheet, so please review the video if you need, and prepare your questions.